So that in the first order reaction, time required for completion of 99.9% is 10 times of half-life of the reaction. So in this question, we have to make a relation between the total time taken and the half-life of the reaction. So basically here, if we have any reactant, this reactant will form a product. So when the reaction just started, at that time, we assume that time is 0 seconds. So all the concentration of the reactant is, let's assume, R naught. That time product is, concentration is 0. But when the reaction is completed 99.9%, that time the reaction will reach to the certain time. So let's assume that time the time is capital T. When the reaction completed 99.9%. So 99.9% can also be written as 0.999. So if initially we had R naught concentration and we know that 99.9% of the reaction is completed, so definitely there is a loss of the concentration of the R. So what is the new concentration of the R? It is written as R naught minus 0.999 R naught. And whatever the loss happens in the reactant side, it will be deposited on the product side. So this is our value of the product. Now if we solve it, it's coming 0.001 R naught. So this is the concentration of the reactant when the time is capital T. So we have to relate the relation that total time T is equal to 10 times of the half-life reaction. So this relation we have to prove. So let's start proving it. So to prove it, we need to remember one relation. Half-life reaction for a first order reaction is 0.693 divided by K. So this formula is only applied for first order reaction. And what is another formula to find the rate constant for the first order? K is equal to 2.303 divided by time log R naught divided by R. So this is applied when the time is equal to 0 and this is applied when time is equal to T. So we are going to relate these two reaction. So how we can relate it? So if we get the value of K and we substitute it here, so we can find the relation between half-life and the time taken. So let's continue this. So based on this relation, can we write K is equal to 0.693 by T1 by 2, and this value we can substitute it out. Let's take this is the second relation and this is the first relation. So this we are getting from first relation. Now K value is 0.693 by T1 by 2. It's equal to 2.303. Time is capital T log initial concentration is R naught and the final concentration is 0.001 R naught. So based on this relation, this R naught gets cancelled. So 0.693 divided by T1 by 2 is equal to 2.303 divided by T log 10 to the power 3. Further, 0.693 divided by T1 by 2 is equal to 2.303 divided by T into 3. So we need to know that log 10 to the power 3 is equal to 3 log 10 and log 10 is equal to 1. So it's equal to 3. So now based on this we can write it as 0.693 divided by T1 by 2 is equal to 6.909 by T. So T is equal to 6.909 divided by 0.693 into T1 by 2. So it can be almost near to 10 times. So this is 10 here. So based on that, we can write our relation T is equal to 10 into T1 by 2. So that we had to prove.